Okay, so in this video, we are going to go over an example such that you have to use the inverse. And so we're still asked to find the solutions on an interval from 0 to 2 pi, and of course, to find a general solution. Okay, so if you take a look at the equation here, it looks like this is a factorable quadratic equation, right? And so you can start by factoring. And I'm going to try 3 cosine of theta over here. And factors of 15, right? 3 times 5, that will give you 15. And then, factors of 8, such that if I fill in these last two terms that are going to give me -2 here, right? You would have +2 and -4 is equal to 0, right? You can double check, right? This is 10 cosine of theta, right? This is -12. -12 plus 10 will give you -2. Okay, so you still have to remember how to factor. Okay, so use the zero product rule. You're going to get 3 cosine of theta plus 2 is equal to 0. And over here, you're going to get cosine of theta is equal to -2/3. If you set this guy equal to 0, you're going to get 5 cosine of theta minus 4 is equal to 0. And just moving the 4 over and dividing by 5, you're going to get cosine theta is equal to 4/5. Okay, so this is where the concept comes in. Notice these values are not exactly on the unit circle. And if it's not on the unit circle, it doesn't mean there is no value of theta such that, the x is -2/3, right? There is no value of theta such that's 4/5. It doesn't mean that. What it means is you can use your arc cosine. And in order for you to use your arc cosine, right, you have to recall a couple things, right? You have to say, hey, remember that y is equal to arc cosine of x, right? If and only if cosine of y, right, is equal to x, right? These are equivalent expressions. And really what you have to remember, right, is that this number right here, right, x has to be between -1 and 1. And whatever's inside the argument, right, this y has to be restricted from 0 to pi, right? So this is way back in chapter 4. I'm sorry if you didn't quite see that. And so if I look over here, right, this number, which is out here, which is my x, right, in order for me to use my arc cosine function, this number has to be between -1 and 1, and it is. Same thing, right? 4/5 is about 0.8, right? This number is also between -1 and 1. So we're good to go, right? So when you take the arc cosine, you will get a number, so you won't get any undefined value. Okay, so this is always good to go back and review. It's in chapter 4. Okay, so if I could use the arc cosine feature or function, right? Theta is going to equal to arc cosine. You could write cosine inverse, but I want to use arc cosine of -2/3. So this would be the exact value, right? And if you want the approximate value, right, this is where you enter this on your calculator. So if you enter arc cosine of -2/3 on your calculator right here, make sure you hit the second button. Oops, I need to turn this on here. Second, arc cosine, and make sure you are in radian mode, which I am over here. -2/3. And you are going to get approximately 2.3 radians. Okay, so approximately 2.3 radians. And over here, if you enter arc cosine, theta is equal to arc cosine of 4/5. You enter that on your calculator, do the exact same thing, arc cosine of 4/5, you will get approximately 0.643 radians. Okay, now, both of these answers, right, fall within the specified interval from 0 to 2 pi. But before I move on to the general solution, right, remember cosine right here is negative in quadrants 2 and 3, right? So this 2.3 radians right here, right, 2.3 maybe somewhere over here. Right? If I, enter cosine 2.3 radians, I'm going to get negative 2/3. But remember, cosine is also negative in this quadrant, right? Quadrant number 1, 2, 3, right? And so if I ask you, what is another solution to this? You would say, well, it's negative 2.3 radians, right? So actually, if you wrote theta is negative 2.3 radians, again, we don't need to write the word radians. It's just implied if the units are not written to be in radians. If you enter cosine of negative 2.3 radians, you will also get negative 2/3. So if you don't believe me, you can enter this on your calculator, right? Negative 2.3 radians is cosine of negative 2.3. You will also get negative 2/3. Okay, but we're not going to use this answer right here, right? Because, this answer right here, because it falls out of the interval from 0 to 2 pi. Okay, so this will be useful when we do the general solution. So same thing over here, right? If I ask you, hey, where is cosine also positive besides quadrant 1? If you just quickly draw the, a diagram, right? We said cosine of 0.643 radians will give us 4/5. So I don't know, 0.643, somewhere over here. If I ask you where else is cosine positive, it's also positive in this quadrant, right? And so how would I write this answer? You would say theta is negative 0.643 radians. So actually another solution would be negative 0.643, right? Again, I'm not going to include this answer because it's not inside the specified interval from 0 to 2 pi, but you will see me use these answers in the general solution. Okay, so this is really critical because when you enter arc cosine of 4/5, your calculator only gives you this answer, but you know your unit circle, right, where cosine is positive in 2 quadrants, positive 0.643, negative 0.643. Positive 2.3, negative 2.3. It's because the fact that cosine right here is negative in quadrants 2 and 3. Okay, so let's finish this problem here as it relates to the general solution. So for part 2, based on what you know of what I just explained over here, right? If I want all the solutions, I'm going to say theta is equal to arc cosine. I'm missing a C here. Of negative 2/3, or 2/3, right? That's basically what I have over here, 2.3 radians, which is this as an exact value, plus 2 pi n. But I just explained to you, right, theta can also be negative 2.3, right? So how would I write that? I would say theta is negative arc cosine of negative 2/3 plus 2 pi n. Okay? And then same thing over here, right? If I want the general solution, I could say theta is equal to arc cosine of 4/5 plus 2 pi n, right? That will only take care of this solution, which is this solution right here, right? This is the exact value, this is the approximate value, but I also need this. So how do I state that? I would say theta is negative arc cosine of 4/5 plus 2 pi n. Okay, so this type of problem is a little bit on the trickier side, but it's really important for you to understand this concept that cosine is positive both in quadrants 1 and 4. It's negative in quadrants 2 and 3, and how that impacts your overall answer, right? I didn't include this in part 1 is because these guys are defined only from 0 to 2 pi on the specified interval. But when you're asked to write all the solutions, your calculator is not going to give you this solution or this solution. You have to kind of sketch it out and see that there are many other solutions based on what quadrant you're in, based on the based on the sign of your arc cosine. Okay, so